Hello guys, welcome to the first molecular science presentation. In this one I'll be covering the first part of nomenclature. So the learning objectives for this one is to know and understand the basics of nomenclature, to be able to name basic organic molecules, and to be able to recognize and draw an organic molecule based on its name. So first of all, what is nomenclature? Well, it's a naming system that we use for molecules. So a few examples of these include methane, ethane, ethanol, ethanoic acid, propene, benzaldehyde. They're all examples of molecules that we have given a name based on the IUPAC naming system. So every organic molecule consists of a carbon skeleton. So if it's got one carbon, then it's meth. If it's two, then it's eth. 3, then it's prop. 4, then it's bute. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. And 10 is dec. But the way that's easiest to remember these is obviously once you get from 5 and above, you go to like the Roman numbers, like pent obviously meaning like a pentagon, 6 meaning a hexagon, and so on and so forth. But these first 4, you've got meth, eth, prop, and bute. And a really good mnemonic to remember these is monkeys eat peanut and butter. Yep. So M, monkeys, E, eat, P, peanut, B, butter. Then once you remember these, everything will be a breeze. So just remember, monkeys eat peanut butter. So carbon has the ability to not only form single bonds, but it can form double and triple bonds. So if it's a single bond, it's called an alkane, and the prefix ends with ane. So the double, then it's an alkene, so it ends with ene. And if it's a triple, that's an alkyne, so it ends with ine. These bonds can occur in several positions along the carbon skeleton. So for example, in decfluorine, the double bond is on the 4th carbon. So if you look here, from here, there's the first carbon, there's the second, there's the first. There's the 4th carbon here, then there's the double bond here. So dec 4 indicating where it is, and the ene telling you it's a double bond. And also when a functional group or a double/triple bond is introduced, they are named based on the longest possible carbon chain and the closest possible carbon. So for example, this is butan 2-ol. Okay, so the hydroxyl group here is on the 2nd carbon. Okay, you would not name it as butan 3-ol. Counting this way, it's always from the closest possible. So 1, 2, it's on the number 2 carbon, hence why we call it butan 2-ol. So here's the first test yourself section. So I want you to name these molecules. I'm not going to give you the answers, I'm just going to flash them up on the screen, draw them down, and then I want you to try and name them. So here's number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and last but not least, number 10. So quickly just jot them down and try and give them their corresponding names. Okay, so moving on. We're now coming to functional groups. So these are the groups which are attached to the carbon skeleton. So examples of these functional groups can include another hydrocarbon chain, an alcohol group, amine, amide, aldehyde, ketone, or even a carboxylic acid. Okay, so we'll start off with hydrocarbons. So these are categorized by having a hydrocarbon appendage. The naming of the compound, remember, is always based on the longest possible carbon chain. So to start off with, we're going to have 2-methylpropane. So here's 2-methylpropane. So the longest possible chain is 1, 2, 3. So it's 3, that tells us it's monkeys eat peanut. Peanut meaning propane. And this extra appendage is located on the 2nd carbon. That's the methyl group. So it's going to be 2, the carbon that's affected, methyl, which is the group attached, and then propane, which is the longest possible chain. Then we've got 3-methylpentane, so the longest possible chain, 1, 2, 3, 4, 5. So it's a pentane, because no double bonds. We've got on the 3rd carbon, we've got a methyl group, so it'll be 3, carbon affected, methyl, which is the extra group, pentane. A little bit more tricky, we've got 2,3-dimethylpentane. So to recognize this, our longest possible chain is 5 carbons. Mass dying, so we've got 1, 2, 3, 4, 5. So it's a pentane. 2, 3 tells us the carbons are affected, so we've got carbon number 2 and carbon number 3. And each of them have got a methyl group, so we say it's dimethyl, meaning 2 methyls. And finally, a more difficult one, we've got 4,4-diethyl 1-hexene, or you could call it hex-1-ene. Okay, So longest possible chain is 6, so 1, 2, 3, 4, 5, 6 carbons long. It's got a double bond, so this is where the prefix is going to start, so it's going to be a hex 1ene, so we're going to count from this way. So the carbon that's affected is 1, 2, 3, 4. It's the fourth carbon, so we've got 4, 4. And each of these has got the ethyl appendage, so it's going to be 4, 4, di for the 2 ethyls, and ethyl hexene. Then moving on, we've got alcohols. So an alcohol is categorized by a hydroxyl group being attached. So first one is methanol, so CH3OH, and here it is. This here is the hydroxyl group, the OH. Then we've got ethanol. So here we've got the hydroxyl group. We've got propanol. Again, if you notice for these, all the hydroxyls are on the first carbon along the chain. Then we've got propan-2-ol. So here we've got propane, the longest possible chain. On our second carbon, we've got the hydroxyl group. And moving on to amines. So amines are categorized with a nitrogen atom. And amines can be further broken down into 3 groups. We've got primary amines, which is when only one carbon is attached to the nitrogen. A secondary amine, which is when 2 are attached. And a tertiary, when all the hydrogens are not attached to the nitrogen and you're just left with the hydrocarbons chains around it. Okay, so now we're just going to name a few basic amines. So we've got methanamine. So here's methanamine. As we can see, it's a methyl or methane attached to the amine. So it's methanamine, or sometimes called methylamine, depending on which naming system you're using, whether it's systematic or IUPAC. Here we've got dimethanamine. So we've got 2 methyl groups attached to an amine group. So this is the secondary amine. So it's di, meaning 2. Methane tells we've got 2 methanes and the amine group. And here we've got trimethanamine or trimethylamine, depending on which naming system you're using. So this is categorized by tri, meaning 3. Methanes meaning the groups attached. So trimethane, and here we've got the nitrogen in the middle, so it's an amine, so trimethylamine. And down here we've got ethanamine. So here we've got 1, 2, so the longest possible carbon chain is 2, so it's ethan. And here we've got the amine. Then over here we've got a secondary amine. So here we've got N-methylethanamine. So here we've got the ethyl group. So it's going to be an ethanamine. Then here we've got the methyl group. So it's going to be N-methyl, telling us the group attached to the secondary group. And the longest possible carbon chain, which is this, will be N-methyl ethanamine. And a more complicated one, here we've got N-ethyl, N-methyl 2-propanamine. So we can start off with the longest possible carbon chain. So we've got 1, 2, 3. So it's a propanamine. However, the nitrogen is attached to the secondary carbon, so it's going to be 2-propanamine. And the groups we've got attached, we've got an N-ethyl group here. Then we've got an N-methyl group here. So the name of it will be N-ethyl, N-methyl 2, carbon affected, propanamine. Then we've got amides. So these are categorized by having an amine group with a double bonded oxygen on the same carbon. So here we've got ethanamide. So imagine that this oxygen wasn't here, it would be an ethanamine. But because we've got this double bonded oxygen onto the same carbon bound to the nitrogen, it's an amide. So 1, 2, ethan, then we've got the amide group here, so it's ethanamide. Then the same thing here, we've got propanamide. And here we've got butanamide. Then we've got aldehydes. So these are categorized by having a double bonded oxygen on the first carbon in the carbon skeleton. So here we've got ethanol. So here the double bonded oxygen is on the first carbon. We've also got propanol. So here on the first carbon, and then butanol. So again on the first carbon. Then we've got ketones. So these are categorized by having a double bonded oxygen not on the first carbon. Okay, so remember that, not on the first carbon. So it's anywhere else but the first carbon. So here we've got propanone. Then we've got butanone. Note we don't need to put any number prefix on these because it doesn't matter which side, which one of these it's on, it will always be the secondary carbon. When it gets along ones like this, so 2-pentanone, so it's on carbon number 2, and then we've got the ketone. and here we've got 3 pentanones. So we've got pent, which is the longest carbon chain. Then on the 3rd carbon, we've got the ketone. And finally, we've got carboxylic acids. So these are categorized by having a double bonded oxygen and a hydroxyl group all bound to the same carbon. So here we've got methanoic acid. So here's the double bonded oxygen, and here's the hydroxyl group. This is ethanoic acid. So you've got the longest carbon chain, which is 2, double bonded oxygen and the hydroxyl group. Then we've got propanoic acid. So we've got 3 carbons, and then we've got the hydroxyl group and the double bonded oxygen. And then a bit of a stronger acid, we've got propandioic acid. So this propane has 2 carboxylic acids on it. So we've got one here on the 1st carbon, and another one here on the 3rd carbon. So this is propandioic acid. Okay, so now we come to the test yourself section. So for 10 marks, I want you to draw these molecules: methanoic acid, pentoene, decanoic acid, heptanthiol, pentanal, 2-methylpentanthreol, octane, N-propyl N-ethyl nonamine, ethine, and butanamide. So for those 10 marks, try and draw those 10 molecules. Then here, I want you to name these 6 molecules for 6 marks. Okay, so they're all there. I hope you enjoyed the presentation, and I hope you're now a bit more comfortable with basic nomenclature. So thank you for watching, and good luck revising. Peace.